So, hello world, Kinuthia here. So, recently I've gotten into Elixir. I want to learn Elixir. So, I decided I'd be sharing whatever I learn with you guys. For one, because, yeah, we are the world. We need to, share whatever we learn, right? Open source and whatnot. Yeah, kind of. And secondly, because I think it will make me better at Elixir. If I learn something and I teach it to someone else, I think I'm that much better at it. So, in a way, all of you are my rubber ducks. Huh. So first things first, so if you want to follow along, you'll have to also install Elixir, and they have pretty good documentation on how you do that. I'm on Mac, so all I did was install Elixir. If you're on Unix, everything is there. I used to use OpenSUSE once upon a time. Yeah, it doesn't seem too complicated to have it installed. So head on there, and after you're done, you should be able to go to your terminal. Oopsie, forgot to escape. So go to your terminal and put in that command elixir-v. Did I say Elixir? I meant Elixir. Elixir-v for version. And that's the version I'm currently running. Most definitely you'll be playing this video in the future, so I don't know if this is the current version. I doubt it will be, but I don't know. Let's see if we can put in 2 dashes version. Yeah, that also works. Another way of knowing whether you have it installed is to simply try and run the command IEX. It will first of all tell you the version you're running, and at the same time put you into Elixir's REPL, read, evaluate, print loop. So here we are able to put in commands and see the result. So if you put in 2, you get 2 as the result, 3, 3, you get the idea. You can even put in basic statements, 2 plus 2, 4. Perfect. So lesson number 0 is data types, and the first data type we shall start with is integers. And integers are basically that, integers, what can I say, counting stuff. So you have positive or negative integers. Yeah, that's all. So the only question is, how do you want to represent your integers? We've been accustomed to using base 10, so that's the numbers you are used to. A dozen is 12, a gross is 144, so that's base 10. But there are other number systems out there. So we have base 2, which is what the computer hardware uses. I think so. Maybe. Correct me if I'm wrong. I'm largely right, but still wrong. So if you want to represent like the number 3 with binary, you start with 0, then B. So that's like the prefix you have to put in before putting in your binary. So the binary number 3 means that's 2 plus 1. So 1, so that it's 2, and 1. So 1, 1, that should be 3. Let's do a harder one. 75. Can I do 75? Okay, sure. Challenge accepted. 75. So 75, we need to go. So 1, 2, 4, 8, 16, 32, 64. So all the way up to 7. So 1, 2, 3, 4, 5, 6, 7. So 75 minus 64, that comes to 11. So we need to represent 11. So 1 for the 1, 2 for the 2, and that is 4, which we need a 0 at 8. Perfect. So delete those 2. That should be 75. Look at that. Thank you. I just do what I do. So after that, after binary, we also have octal. So to represent octal, it's 0 and O, and octal is base 8. So if you want to represent 8, it's, I believe, 1, 1, if I'm not mistaken. No, that's 9. I wonder why. Okay, I don't have the patience to do that right now, and this was not a lesson on number systems, so I'll make sure I drop a link down there if you want to get more familiar with how all these number systems work. And finally, the last one is hexadecimal. So hexadecimal, if you want to put in your numbers, your integers as hexadecimal, start with a 0, then an X, then put in whatever you want. So hexadecimal goes all the way up to F, so you can put in like, let's see this number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then you have to stop, then A, B, C, D, E, F. So let's see what that brings up. So that's the number, whatever number that is. What's that? 1,000, million, I don't know. I wish I got that as my bank account balance. But yeah, that is that. So in summary, no, before we go to the summary, I want to show you something really cool. So import file. So this is a simple function I wrote a bit earlier to enable me to do factorials. Don't worry, after like several hours of watching my videos, or maybe a couple of days of you going through Elixir documentation, you'll also be able to do the same. So yeah, factorial. So now that file gives me the ability to do this, and I basically feed it a number and then it tells me it's factorial. You know, like 3 factorial is 3 times 2 times 1, so that should be 6. Yeah. So 10 factorial should be 10 times 9 times 8, whatever, on and on and on. And I believe that is quite a big number. It is. What about 100 factorial? Oh, even a big number. What about 1,000 factorial? A really big number. Heck, let's go crazy. 10,000 factorial. I dare you, Elixir, to do 10,000 factorial. Elixir is up to the challenge. Whoa. Look at that number. So this demonstrates something. Integers in Elixir are arbitrarily big. That means they are as big as you want them to be. Simple. So if you ever start a company and you have that number of users, be sure that Elixir will be able to store it somehow. What is this? Like the number of stars in the universe or something? This is like a really big number. I don't know what number this is. But yeah, so in summary, integers, counting numbers, positive or negative, they can be represented in Elixir. Yeah. There are several ways of representing integers. You have the decimal system, base 10, binary system, base 2, octal, base 8, hexadecimal, base 16. And finally, integers in Elixir are arbitrarily big. They're as big as they're required to be. I think the bottleneck is how much RAM or how much, I don't know, how much something you have. So I think you're restricted by your hardware, not by the language itself. So yeah, so that was the first lesson. See you in the next one. Any thoughts or comments, you know what to do down there. Yeah, create an account, log in, and then put in your comment. And be nice. Or not, I don't know. Engage in any way you feel necessary. So, bye for now.